In this video, we are going to learn about units and measurements. So we'll be looking at fundamental and derived quantities in physics. So let's begin with fundamental quantities. So what are fundamental quantities? They are simply those quantities in physics in which other quantities depend on. Alright, so we have basically about 7 of them. So let's begin with mass. Alright, so mass is a fundamental quantity and the unit of mass is kilogram. That is measured in kilogram. Short form is kg. We also have our length. The unit of length is meter. Short form is m. We also have our time. The unit of time is seconds. Short form is x. We also have our temperature. The unit of temperature is Kelvin. Short form is K. Alright, we also have our electric current. The unit of electric current is ampere. Short form is A. Alright, we also have our amount of substance. Amount of substance. The unit of amount of substance is mole. Short form is mol. Okay, we also have our luminous intensity. So the unit of luminous intensity is candela. Short form is CT. Alright, so these are the 7 fundamental quantities we have in physics. Now note that all these quantities here are scalar quantities. As we all know, in physics, scalar quantities are those quantities in physics that have magnitude but no direction. So all the fundamental quantities here are scalar quantities. Alright, so having known this, let's wipe this now. Look at derived quantities. Okay, so what are derived quantities? Derived quantities in physics are those quantities that are gotten by simple combination of 2 or more fundamental quantities. So when you add 2 or more fundamental quantities, it will yield or give you a derived quantity. So let's look at a couple of them. We have area. Area is one of them. So as you know, to calculate area is calculated using length times breadth. Okay, and its unit is meter square. We also have volume. Volume is calculated using length times breadth times height, and its unit is meter cube. We also have density. Density is calculated using mass over volume. So the unit of density is kilogram per meter cube. Right, so we also have our speed. So speed is calculated using distance over time. So this is n, distance over time, and the unit of speed is meter per second. Alright, so we also have our velocity. So velocity is calculated using displacement over time. Displacement over time, and it had the same unit with speed, meter per second. Now the difference between speed and velocity is that speed is a scalar quantity, whereas velocity is a vector quantity. Speed has magnitude but no direction, but velocity has both magnitude and what? Direction. Alright, so we also have acceleration. Acceleration, which is calculated using velocity over time. Alright, so the unit of acceleration is meter per seconds square. Okay, we also have our force. So force is calculated using mass times acceleration, and the unit of force is Newton. So the short form is N. Okay, we also have our weight. Now, weight is calculated using mass times acceleration into gravity g, and its unit is also measured in Newton. N, short form. Alright. The difference between weight and mass is that mass is a scalar quantity, whereas weight is a vector quantity. Alright, so that's just the major difference between weight and mass. Alright, so let's look at another example of a derived quantity. Okay, we also have our momentum, which is calculated using mass times velocity. Alright, so the unit of momentum is Newton second. The unit of momentum can also be kilogram meter per second. So any of these can serve as the units of momentum. Alright, we also have our pressure. Pressure is calculated using force over area, and the unit of pressure is Pascal. Alright, so you can also have other units, but the common unit is Pascal. Okay, so let's wipe this and look at a few more examples. Okay, so we also have work, which is calculated using, so work is calculated using force times distance, and each unit is joules. Short form is, we also have energy. Alright, energy, there are various ways you can calculate energy. We have kinetic energy, we have potential energy. Alright, MGH, you can calculate energy using MGH. You can also calculate using half mv square. Alright, depending on the type of energy you are dealing with, and each unit is also joules. Energy is also measured in joules. Okay, now it depends. You can also calculate energy using force times distance, depending on the situation you have. Alright, so energy is a derived quantity. The difference between energy and work is that energy is a scalar quantity, whereas work is a vector quantity. Energy has magnitude but no direction. Work has both magnitude and direction. Okay, we also have our power. So power is calculated using work over time, and is measured in watts. Alright, so we also have our impulse. So impulse is calculated using force times time. Okay, so the unit of impulse is Newton second. We can also measure impulse in kilogram meter per second. So anyone will work. Okay, so these are the basic derived quantities we have in physics. We have others, but these are the basic ones. Alright, so with this we have come to the end of the class. Now know that you should get yourself familiarized with these various quantities and their units, because they are very important. It will help you in the discipline of physics in the long run. Get yourself used to them if you want to be a good physics student. Alright, so that's for this class. Thanks for watching. Hope you learned something interesting. If you are new to the channel and you have not yet subscribed, show you the subscribe button now to subscribe to the channel for more videos. So like, share and comment on this video to tell me how you feel regarding what you have learned from this class. If you seem to have any specific questions to ask, feel free to leave your question in the comment section below, and I'll be sure to give you a response. That is for this class, guys. Thanks for watching.